For an individual weak acid or weak base component, see buffering agent. For uses not related to acid-base chemistry, see buffer. A buffer solution is an aqueous solution consisting of a mixture of a weak acid and its conjugate base, or vice versa. Its pH changes very little when a small or moderate amount of strong acid or base is added to it, and thus it is used to prevent changes in the pH of a solution. Buffer solutions are used as a means of keeping pH at a nearly constant value in a wide variety of chemical applications. Many life forms thrive only in a relatively small pH range, so they utilize a buffer solution to maintain a constant pH. In nature, the bicarbonate buffering system is used to regulate the pH of blood. Applications: buffer solutions are necessary to keep the correct pH for enzymes in many organisms to work. Many enzymes work only under very precise conditions. If the pH moves outside of a narrow range, the enzymes slower stop working and can denature. In many cases, denaturation can permanently disable the catalytic activity. A buffer of carbonic acid and bicarbonate is present in blood plasma to maintain a pH between 7.35 and 7.45. Industrially, buffer solutions are used in fermentation processes and in setting the correct conditions for dyes used in coloring fabrics. They are also used in chemical analysis and calibration of pH meters. The majority of biological samples that are used in research are made in buffers, especially phosphate-buffered saline at pH 7.4. Simple buffering agents for buffers in acid regions. The pH may be adjusted to a desired value by adding a strong acid such as hydrochloric acid to the buffering agent. For alkaline buffers, a strong base such as sodium hydroxide may be added. Alternatively, a buffer mixture can be made from a mixture of an acid and its conjugate base. For example, an acetate buffer can be made from a mixture of acetic acid and sodium acetate. Similarly, an alkaline buffer can be made from a mixture of the base and its conjugate acid. Universal buffer mixtures. By combining substances with pKa values differing by only 2 or less and adjusting the pH, a wide range of buffers can be obtained. Citric acid is a useful component of a buffer mixture because it has 3 pKa values, separated by less than 2. The buffer range can be extended by adding other buffering agents. The following mixtures have a buffer range of pH 3 to 8. A mixture containing citric acid, monopotassium phosphate, boric acid, and diethyl barbituric acid can be made to cover the pH range 2.6 to 12. Other universal buffers are the Carmody buffer and the Britton-Robinson buffer, developed in 1931. Common buffer compounds used in biology. For effective range, see buffer capacity above.